Hello and welcome to my tutorial. Mr.net is here and today I'm talking about the decorator pattern. The decorator pattern has several components. For example, we have an interface and a class what is implementing this interface. And for example, I want to extend this class. And for example, I can't implement here a method because we have some design principles in the object-oriented design that says, for example, the open-close principle, that a software has to be open for extensions and closed for modifications. So I can also implement more components, and every component provides a responsibility or a function. And if I want to combine the component C with the component A, I can also implement a fourth component. And I can also implement for the other components a component to combine other components. But you see, you have a lot of components. So for that, we can use the decorator pattern. We can extend the responsibility of a class without modifying this class. So I implement a decorator. It is an abstract class or interface. This decorator extends or implements also the interface what is implemented by the class what we have to extend. And the decorator also has a value which is from the type, from the iComponent type. For what we use that, I explain the source code. And then I implement some classes what I want that implemented the decorator, and each decorator implementation provides as own responsibility to extend this component. So, for example, I have a component, and this component is wrapped by the decorator A, and the decorator A is wrapped by the decorator B. So when a client is calling the decorator B calls decorator A, and the decorator A calls the component. And also the return value goes back to the decorator A, and the decorator A gives the return value to the decorator B, and the decorator B returns the value to the client. Now if we look into the source code, I have here a program that contains an interface, the interface iComponent. This component has a method, the trim method. This method takes an argument, a string argument, and returns a char array. Then I have the concrete implementation of the iComponent, which implements the method. And this method takes the argument and trims this argument. That means that it cuts every space in front from the string and after the string. Then I translate it into a char array and return it. Now I can show this in my program. I have here a string with spaces, hello world, underline 1, 2, 3. Now I can create a component . Component.trim. And if I start the program, we see the original and then the component arrow hello world. That's the method from my component. And now I want to extend this component with decorators. So firstly I create a decorator. It is only a class decorator. This decorator is an abstract class. It can also be a interface. It implements the eye component and also the method from the eye component. Then every decorator needs a member which is from type eye component. I explain it in the video. You will see why we use that. So that's protected eye component, and in the constructor I get the component and set the component. So that's my decorator abstract class, and now I need the concrete decorators. For that I create a concrete decorator called Decorator A, and this decorator inherits from the decorator class. Decorator A has a constructor which takes as an argument a component, and in the base class I set the component. So now we have in the base class a component. Now this method I need to override in my subclass. So here I implement the public override trim method, and this trim method is doing something. For example, my component trims every spaces, so my decorator R has to trim every upper space letters. So for that I create a regex object. This regex is not a component from the decorator, but I need this only to show you how the decorator works. And this method takes this argument and trims every uppercase letter from the given argument. So I take only a for each loop, and if regex is a match from C or is not a match from C, I can let it into the value. So I take here a string builder, string-builder.append C, and in the return value we see that this method returns a char array, but I have to delegate the invoke to the component what was given in the constructor. So I return here from the base class the component trim method, and return, and the argument is not the value, it is the string builder as a string. C2 string. So I give the value as an argument, I iterate through the value, I cut every uppercase letter, and then I invoke the component what is given in the constructor. So I can also implement more decorators. I copy this class and rename it only to Decorator B. That's the Decorator B. And the Decorator B cuts every every lowercase letter. The implementation is the same. I can also copy the Decorator B and create the Decorator C. This decorator cuts every number from the given string. So that's my decorators. Now I show you this in the program and you will see how the decorators work. So I create a new component. Number 2. So this component I didn't need, and I call here the second component. So if I call the program, you see this is my string. And now I can add to my component the decorators. So I say new decorator A, and this decorator takes an argument, this component. And now when I start the program, you will see every uppercase letter will be deleted, because that's the functionality from the decorator A. I can also extend the functionality with the decorator B, for example. So if I now start the program, yes, you see every lowercase and uppercase letter is deleted. And I can, of course, take the decorator C and delete every number from this string. And the result is only the underline and this sign here. And you can dynamically delete the decorator, which you don't need, and extend your functionality like you want. So that's the decorator pattern. I hope I explained it so that you understand it a little bit better. If you like this video, please give me some recommendations, and hopefully I see you in the next video. Bye!